Good morning, good afternoon, and good evening, wherever you are. We are a group of Italian students from the University of Salento, passionate about modeling and data management, and we present here our work. We have tried to respond to the request received by UNICC for the Refugee Crisis Predict Forced Displacement Challenge, whose aim is to develop a model able to predict future refugee population figures by country of origin in 5 years' time. Emigration, as can be seen in the graph presented, has a constantly increasing trend over the last 50 years. Focusing on the period between 2010 and 2019, it is possible to notice an even more significant impact of this phenomenon, so much so that in this period there has been a percentage increase of 174%, reaching a final value of 68 million euros. As can be seen from the graph provided by Uppsala University, conflicts divided by type of violence are concentrated primarily in two areas of the world, Central Africa and the Middle East. In fact, as we will see shortly, it is precisely the countries belonging to these two macro areas from which most displaced persons come. It is therefore possible to understand the importance of conflicts in the migration phenomenon. The answer to the previous question is yes. In the graph presented, in fact, we note that the countries of major origin of displaced persons are Syria, Afghanistan, Yemen and Sudan, countries belonging to the conflict areas mentioned above. Since most of the displaced people come from the countries highlighted in the previous graph, through this map we can highlight how the number of victims caused by migration is higher in the same countries and in other countries belonging to the same geographical area. The highest number of deaths is in Afghanistan, Syria, Iraq and Yemen, countries that, as seen above, have a high density of conflict and are among the first countries of origin of those who emigrate. We then asked ourselves, which countries are taking the most refugees? Here, we can note by both sides the countries with the largest number of refugees. Turkey turns out to be the first, as might be expected to the geographical proximity to the countries seen above. Thus, there is also a correlation between geographic proximity and fewer conflicts between the host country and the refugees' country of origin. In the proposed chart, we also see an increase in the number of asylum requests still unprocessed. Of interest to us was also assessing to understand whether the country with the most refugees was also the one with the most pending asylum claims. Our research did not lead to the identification of this correlation, so much so that the country with the most unresolved asylum claims is the US.
So, what will be our prediction for the forced displacement 5 years from tomorrow? For the first category, the people displaced abroad that obtained the refugee status, called REF. The developed model provides a robust result. We detect the following countries of origin for displaced refugees: Sudan, Sweden, Afghanistan and Ukraine. In this slide, we can see countries of origin for asylum seekers who are still waiting for an answer in 2024. As shown, countries with the highest values are Yemen and Guyana. The 2024 forecast for IDP, internally displaced people, predicts Turkey and Ivory Coast to be the countries with the highest international displacement. In relation to the latest geopolitical events, it can be deduced that our analysis is realistic. In fact, Ukraine is currently characterized by political instability. Afghanistan is a confirmation of the previous data. Sweden, on the other hand, is an unusual element that we did not expect to find and represent a phenomenon to be analyzed. Finally, from the model created, it emerged that Turkey is the country characterized by the most internally displaced people. This is certainly due to the fact that it has the greatest number of actual REF. Let's now look at the workflow and models that led us to these results. The pipeline that we implemented for our analysis consisted of the following steps: data exploration, data cleaning, feature engineering, model selection, model fitting, and prediction. For the exploration phase, we had a look to our data, trying to get a current view of the type of information we had in the dataset and its usability. We identified the main features we were interested in and excluded the ones which didn't appear predictive enough or good enough from a data quality point of view. Then we switched to the data cleaning and removed the missing values from our selected features using mean value imputation. Once we had clean datasets as an input, we proceeded with the data engineering part. This mostly consisted of merging the datasets through inner joins. Once the one-hot encoding of the origin country and other categorical features like continent, colonizers was performed, we had about 300 features in total. Each row of the table corresponded to an observation for a given origin country in a given year. For each one of these possible inputs, we computed the corresponding outputs, working under the assumption of independence of the observation for a given country at different times. We therefore explored several machine learning models for the multiple regression. The model was ultimately the random forest, which we fitted of data after splitting in train 80% and test 20%. Lastly, we predicted the REF, IDP and ACI for 2024, 5 years ahead starting from 2019 data. Technologies we use for the modeling part are mainly based on Python, in particular Pandas for the data management and sklearn for the model implementation, while we use Tableau and Canvas for the visualizations. Thanks to the usage of all these tools, we were able to develop our analysis, draw the conclusion we've seen and set the ground for future work. Indeed, the refugee crisis is one of the hottest topics in the current geopolitical framework, and our work is a promising first step towards a deeper understanding of this phenomenon.